Hi, my name is Chintan Jain, and I'm here to talk about the top 10 security things to protect your microservices. So let's start with the introduction. I have about 18 years experience in the information security field, working for various Fortune 500 companies like eBay, Marriott, now Capital One. Also privileged to work with a few early and late maturity startups. I'm an innovator at heart, and I like to innovate. I have about 10 patents, 2 approved, and 8 pending patents, mainly in the area of mobile, social, and local. I love to travel and read, and I really am like explore anything about space. So that's about me. So what are we going to talk today? We are going to talk about, first of all, microservices is a very overloaded term. So the first thing that we will do is we will I will when I talk about microservice, what is a microservice? So I will throw out a couple of slides so that we are talking the same language, we are on the same page. When we are talking about microservice, we are talking about the same thing. And then I will get to the heart of the presentation, which is what are the top 10 things that you do to protect your microservices. And then if time permits, we will have some questions. So what is the objective of this talk? So after this talk, I'm hoping that you will take along this 10 security microservices with you, and you'll be able to release a secure microservices in production. You will send me 1,000 Bitcoins, and then you will live happily ever after. Okay, so let's start with the microservices architecture, right? So since last 3 or 4 years back, right, there was always that monolithic architecture. What that meant was you had a central unit that contained your business logic and your data access layer. So this business logic will be a fat, big application, and it will have all your business functionality. It will, like if you have a banking application, it will have your login functionality, it will have your accounts functionality, your transfer functionality, balance transfers, bill pay, everything will be in one single application. So how that has evolved is we have bombarded that business functionality into several independent applications, and each application becomes a microservice. So if you see this, right, so that business logic and the data access layer has split into several different microservices here. And you don't have one single database anymore. You have 4 different databases. And each of those microservices that you see is a different, it doesn't have to be one kind of application, one kind of technology stack. It can all be different technology stacks. The database that you see doesn't have to be a single kind of database. One can be a NoSQL, one can be a Cassandra, Mongo, it can be a Postgres, it can be an Oracle, it can be anything. As compared to monolithic, where you always had that one single database. So now what you can do is you can pick a database that works for you. So this is one, and then if I have to give an example of that, so a monolithic application on the left side, you see there is one single big central module which has login, identity, and account, and then it is connected to the central data store. And on the right-hand side, all those 3 different business functionality is a different microservice. So login is a microservice. Login and identity both connect to the same identity database, and then you have an account microservice that connects to the account database. Also, if you see the boxes behind those microservices, you see you are scaling up those microservices as per your traffic. So in login microservice, you only see a single box, but in identity microservice, you see 2 boxes, which means that there are 2 servers behind there. And in account microservice, you see 3. If you compare that to monolithic application, you don't have that. You have to, because all of that functionality resides in the same application, you are seeing you cannot scale it or up or down. Whereas microservice, you get that flexibility. So what that has done to the application teams. So on the left-hand side is a monolithic application team, which is about 20 to 40 people, a lot of project managers. And and on the right-hand side is a microservice application team, maximum 5 to 7 people, right? So the reason to do that is now you are not dependent on this big team. If you want to release something in production, then you are not dependent on all these other teams. You can do it yourself, and you can release it in production. So that really increases the pace of development. You are able to do rapid development, and you are able to do rapid deployment in production. As long as your microservice contract, the endpoint that you are giving to the customers is not changing, you can keep on releasing these microservices in production at a breathtaking speed. What that has done to security. So there are no security experts as part of team. Like we release like two or three releases every month. We don't have time, we don't have a lot of security experts on the team. We have to constantly innovate and constantly just deploy. And the team becomes responsible for all aspects of security. So that's why we are here. You have come to the right place. We are going to talk about what are all the top 10 things that you need to do to secure the microservices. So the first top thing that you need to do. So when you have a microservice, what will happen is you will expose an endpoint, an HTTP endpoint, to your customers. And the customers are going to hit that HTTP endpoint. The first thing you need to make sure is whoever is hitting your microservice at that HTTP endpoint is coming through a TLS connection. So you are encrypting all the traffic between the microservice consumer and the microservice endpoint. Now, just encrypting the traffic is not enough. There have been a lot of security vulnerabilities that have been found with TLS 1.0, SSL 3.0, and 2.0. Some of the attacks exploit the weaknesses in the CBC implementation of AES, which is cipher blockchaining mode that a lot of algorithms, like when you use AES or triple dash, that's one of the modes that is being used quite a bit right now. And there are weaknesses. Poodle exploits that weakness, and by that, it is able to play around with the padding to finish the block size, and then they will be able to decrypt session cookies if the attacker is successful. If you have session cookies, it's keys to the kingdom. Like if somebody knows your session cookie, they can create a session, and they can just be you on that website. So protecting cookies we all know is very important. Beast is another weakness that came out that again exploits the weaknesses in CBC implementation. Crime and breach, these two vulnerabilities exploit the TLS compression and HTTP compression. The way the compression is done, they are able to guess based on, they compress. So basically what happens is they are trying to guess based on the compression, and then they are able to figure out the pattern of the encrypted traffic. And then we all know about Heartbleed, which is an OpenSSL vulnerability. So the bottom line is just doing TLS is not enough. My recommendation is you have to use TLS 1.2. TLS 1.2 has stronger signing algorithms, especially the support for SHA-2 family. It supports forward secrecy. So if somebody had to record your traffic and try to find out the session cookie with which the traffic was encrypted, they cannot do that. It supports very good key sizes, and then it does not support some algorithms like AES CBC mode and then insecure RC4 algorithm. So TLS 1.2 will give you a lot of this inbuilt security. So my recommendation would be, if you were to, so you have to do TLS, right? If somebody is hitting your microservice, and you have to use this cipher suites. And if you see, Diffie-Hellman, ephemeral, elliptical curve, Diffie-Hellman, elliptical, all of those algorithms with a very secure SHA-2 family for signing. Now, there might be cases where some of your clients will say that we cannot support TLS 1.2 because they are using some older version of an application. So you may allow TLS 1.1, but I would really recommend, if you are creating a new microservice, you try to force them to use TLS 1.2. Now, once you let the customers come to your endpoint using SSL, the other thing that you need to do is you need to make sure you're authenticating your API customers. So one of the things that I see, microservices is like your home. So if you are permitting somebody from your front door, you need to make sure you know who they are, right? Now, you can have a lot of microservices customers. So a microservice can be your consumer, web services can be on consumer, mobile apps, Internet of Things, web applications, or end users. Any of these actors can consume your microservice. And you have to design your authentication mechanism to see which actor you are permitting. So if it is another service that you are permitting, then they will have a static API key. Like a lot of legacy applications already use static API key. I don't like it, but still, like if they can protect that static API key, then that's one of the things that you can do. But again, like static API key security is not very good, because if somebody knows that static API key, they will continue to hit your microservice with that static API key. Username and password is something that we are already using. If the end users are consumer microservice, then they will use the username and password. Client ID secret is another thing that the microservices or web applications or the web services can use to authenticate. Cert-based mutual auth. So again, if you have an internal application, like a microservice which is used by internal customers, then this is something that you can do, where you can give a certificate, a client certificate, to those services, and then they hit you with that certificate. So that is a mutual auth that you can do. OpenID, yeah, okay, I skipped that. So thanks for letting me know. OpenID Connect is another protocol that is emerging, and you can use that like to do authentication along with the JSON web-based tokens. And again, SAML is one of the older standards. It uses XML, but again, like if you are using that technology, then that is another thing that you can do for authentication. If your microservice is a very high security use case, then you may use a one-time PIN along with one of those mechanisms that I already mentioned, or you can do a biometric, a device fingerprinting. Like when the customers are hitting your microservice, you will drop a cookie on that device, or you have some kind, if it's a mobile app, then you have a device ID, and you know that this particular person always comes from this device. So those are all the multi-factor authentications that you can put if you have a very high security use case. Short-lived certificate is something that Netflix uses, and it's pretty secure, but it's very hard to pull off. So unless you have a lot of automation, you would not be able to, like, it is a hard thing to pull off, but again, that is one thing that is very secure, and you can go with that. And you can go to Netflix blogs, and you can read a lot about it. The third thing that you do, right? So if you let somebody enter your home, now based on who that person is, you will permit them entry to some rooms, or you will not permit them entry to some rooms. Like if it's just a solicitor, I will not even make them enter my home. I will just look at from my front door, and I will just talk to them and say goodbye. But if it's a very formal person that comes to me, then at the most they will sit in my living room. Similarly, like if you are letting somebody come to your microservices, you need to make sure that the authorization is performed. And it is not just performed at the front layer, but it is performed even after they enter your microservices world. Every component that hit, they need to be authorized. So it can take, so there are a lot of protocols emerging, like user managed access. UMA is emerging protocol for consent management. But like when we talked about mutual authentication in the previous slide, like when you do mutual authentication, then you will know that this particular certificate name is entering my microservice. And when you give them the certificate, you can provision the permissions for that certificate. So you can say that if the client comes from this certificate, they can only do this operations in a read-only mode, or they can write. So you can do that based on the client certificate. You can, based on the user IDs or however you are identifying the customers, you can do permissions-based and role-based authorizations. XACML is another standard, which is a de facto standard to do fine-grained authorization. That's something, again, you can do. And JSON Web Tokens is something else you can do, where in the JSON Web Tokens, you will have, like the identity provider would put some kind of scopes inside the JSON Web Tokens, like what are all the things that this customer is allowed to do. So you can design your authorizations based on that. And OAuth scopes, like when you are using OAuth as an identity provider, and somebody is using your microservice as a login, like Facebook, right? Let's say that like my microservice is like a Facebook login. then somebody, when they come to me, I make sure that I only give them permissions what are required. So if a client is asking me as an IDP for permissions, I need to make sure that they are not asking for permissions that are not needed for the use case. So I need to enforce that I'm only giving permissions that are really required for the use case. And then if I'm a client in the OAuth world, and if I'm asking permissions, then as a microservices owner, you should not ask for permissions or getting user data that you don't have need to. Because if you're going to ask for all that data, you're going to store all that data. And then if you're going to store all the data, you better protect that data. Because if something happens to that data, then you are responsible if you lose all those data. So only ask for permissions that you really need, and as an identity provider, only give permissions that is really required based on the use case. OK, this is one of my favorite topics, rate limiting, right? So whenever I think about microservice, I think about a freeway. And this is a Los Angeles freeway, which is full of cars and so much congestion, right? If my car enters in that freeway, it will take me 1 hour to travel 10 miles, right? My microservice is like this, where if I just let on keeping these cars enter into my microservices world, they will continue to create congestion on my freeway. And what happens to the next car or the next request that come to my microservice? They will continue to be bogged down as well. And what happens in this case? The people are going to, like whoever is using my microservice, they are going to get really pissed off. And they are either going to go away, use another roadway or a different microservice, or they are just going to not like me, right? So what can we do? So this is a ramp meter. What we have just done is we have created a ramp meter on the entry to the freeway. And now every car that is coming into my freeway, I'm monitoring it. I'm making sure that this particular car, only this many cars can enter my freeway at the same time. And what this has done to my traffic. The traffic is really free-flowing. Cars are moving at the speed that they were promised to do. Similarly, you need to do for microservices. You need to, don't think that your microservices are going to scale infinitely, because they are not going to scale infinitely. If you have, I had one of the team members boast me that when my microservice goes down because of traffic, that will be the happiest day of my life. I don't think so. You don't want that. Every microservice consumer that you sign up, you need to make sure, you need to ask them like how much traffic they are going to send you, and at what time of day they are going to send the traffic. So you need to make sure that you rate limit your customers. They will tell, and then if they are not, so first of all, you will ask them like how much traffic are you going to send me, right? And not just that, you are also going to put rules in place on your microservice that if they send you more traffic than they promised, then either you are going to deny them or you are going to throttle your microservice traffic. So you're going to slow them down. AWS does it, right? Like a lot of big providers already do it. And what rate limiting does is it will make sure that your microservices don't go down like that freeway, and you don't have a distributed denial of service, and your microservice is available and fast to use. OK, the fifth thing that we need to do. We need to make sure that any access that is coming to the microservice, we are logging it. And then we are logging it. We are not just logging it. So you can use like ELK, stack, or you can use like Splunk or something like that. And then you are logging all this traffic, and then you are monitoring for patterns in that traffic. And then if some pattern is not matching, if somebody is trying to hit your microservice in an irregular pattern, then you create an alert. And most of this alert needs to be automated. Like you don't want somebody sitting there and looking at like manually, right? So you are looking at, so this monitoring tool, this logging tools allow you to set up those alerts or alarms. So if something deviates from the normal usage of the traffic, then you will start getting alerts. And you need to do that. And you need to constantly look for those alerts. And then you need to take action if something is going on. So if you see that there are many 500 responses, many unauthorized requests to access the microservices, or many failed attempts to authentication using a valid client ID but incorrect password or secret, somebody is trying to use expired tokens, or service is throwing a lot of 404s because somebody is trying to brute force something, they are trying to like guess a session token or something, and you don't have that. That was part of a URL, and there are a lot of 404s happening. Then you know that something is going on. You can also create patterns like circuit breaker. So if something is happening to your traffic, then you can create alternative mechanism to serve your traffic in case of any problems. This is another very important thing. Even with the cloud, this does not go away. You have to design a secure network architecture on the principles of defense in depth. So at the entry, you need to have a WAF. So all the traffic that is going through, it will do all the application checks, because if you are not doing all the application checks, then it's good to have a WAF, web application firewall, that will do it for you. Then you will have an API gateway, because you don't want to build all that rate limiting functionality that we talked about, because you don't have time. So you will bring in some network components that will help you do those validations. API gateway is a very good component to have there. So anybody who is coming to you, so API gateway cannot just do that, it can also do OAuth, access token, client ID secret, it can do a lot of that stuff. So you don't have to do it. That things is inbuilt in it. Another thing you need to do is your microservice is just going to, so your microservice is going to talk to several other microservices, or it's going to talk to several other APIs, or within the architecture, once the traffic comes to a load balancer, you take it to web servers. The web servers are going to talk to the app servers. The app servers are going to talk to the database servers. Sometimes the app servers are going to talk to different web applications. You need to make sure that you are using TLS, and try to use TLS 1.2 if possible in all those mechanisms also. Now, you may say that we are hosting all these components. So if the application server and web server and database server, they are all living in your data center, and you don't want to do TLS, that should be OK. But you need to make sure that you have that, you are thinking about that, because TLS kind of slows you down a little bit. So if you are in the cloud environment, then again you have to see, because now if you're in a cloud environment and somebody is hitting your instances, and then from there they are going to a database somewhere, you need to make sure that the TLS is being done in those components. If you have CD cardholder data, and if you have PII data, and you have some other data, you need to segment your network. That is very important. You don't want, because if you are processing credit card data, and you don't want all that data to lie in the same environment where you are hosting all the other components. Because if you have to go through PCI assessment, that brings the whole environment in scope, and you don't want that. Again, from a security perspective, it's good to segment your network. And I would say the one would be a CDE network, where you have all the cardholder data. Then you have a PII, where you have all the PII data, and then the generic, where you don't have any, you are hosting just static data. And this is the diagram that you see on the top right-hand corner is from AWS. Again, I just took it because there are a lot of good things in there. So if you see, there is those instances are on the top, and there is a security group, which is nothing but it's like a firewall. So when you are setting up those instances, it tells you what instance can get to my what IP addresses. These are the range of IP addresses, and these are the ports. Only those will be allowed to call the EC2 instance. So it's like a firewall. So they did a good job there. And then if you come down, there is a subnet, which is again a subdivision of the network. So it's like a network segmentation right there. And then there is a network ACL. So if you did not do a good job doing security groups, then network ACL might help you, because it's kind of have the access control rules there. And then you have the router and the routing tables. OK, so now we talked about all of those things, right? But so lately what we have seen, right, just back in March 2017, there was a widespread S3 outage, which caused a massive outage for AWS customers. And it resulted in a $150 million business revenue loss for AWS customers. Now, your customers, if you are hosting this microservice, they don't know, and they don't need to know that you are in a cloud environment. What you need to do is you need to create resilient microservices, right? Because again, is in the availability domain of security. By resiliency, what I mean is resiliency is a summation of system availability and data loss. So system availability means like if I want to use your microservice, will it be available? And if it is available, then will my data be lost anytime, right? So when you talk about resiliency, you talk about system availability and no data loss. So the trend that we are seeing, right, like now a lot of customers using cloud environments, AWS, Microsoft, Google. What happens if one of the components in this cloud goes down? Or if your microservice is dependent on some other microservice, like if you look at like one application, right? You take one mobile application. That mobile application is talking to so many other SDKs that are hosted in the cloud. What happens if that particular component goes down? So from a resiliency perspective, you need to make sure that so first of all, like either you're in a data center environment or a cloud environment, you need to make sure that you are in multi-region. So if that region goes down, you can quickly move your traffic to the other region. So there are a couple of patterns for that. One is active-active, and the other one is active-passive. Active-active means like you are serving your traffic from both the regions. And if something happens, like your Route 53, like we use AWS, so we know that if it will know that this particular region is going down or something because we are seeing a lot of latency, and it will automatically direct your traffic to the other region. So you can follow that. And if you don't want to do that, then at least you need to have active-passive. So you have like you are serving traffic from one region. On the other region, you have your components up and running, but you're not serving any traffic. And if something happens to the availability of that region, you quickly move to that other region, right? So in active-passive, there will be some downtime. In active-active, there will not be any downtime. Again, if it is a cost issue, then you need to look at your application and see how business critical it is. Because some applications are very business critical, you may want to do active-active. For some applications, you may do active-passive. But resiliency is not just about your components which you are hosting. It is also about your dependencies. So if you are dependent on some other services or some other applications, you need to, whenever you are like signing up those vendors, you need to make sure you are asking them that, are you resilient? Because even though you are resilient, and if you are dependent on some other application somewhere hosted in the cloud, and they are not resilient, guess what? Even though you are resilient, if they go down, you have the same impact. So you need to make sure, like when you're choosing vendors, that they are also providing the resiliency. Okay, this is one of the very important things, right? So what we have seen, we have created very secure microservices. We have, like based on the talk till now, we have all the customers coming through very secure TLS 1.2. We are authenticating them. We are authorizing them. We are looking at their access by logging. We are doing the rate limiting. We are doing everything. But even now, what we have done is we are storing our private keys, the TLS private keys, in plain text on the servers. And the system credentials to access the database or the servers, all of those are, like I know that a lot of those credentials are stored in plain text. So if an attacker gets into your servers, they will be able to look at all of this in plain text. So that is the key to the kingdom, right? Like you secured everything else, but you left the chest, the treasure chest in your bedroom unlocked. And now somebody can just come in and take all the secrets from there. So what you need to do is you need to, whenever you're storing the private keys, you need to store them very securely. You can use a physical HSM. Again, this is for very high security use cases. And there are a lot of patterns available where you can generate a key on the physical HSM and use as a key wrapping key. So now you take your private key and then you encrypt it with that, and then you put it on your servers, or you can put it somewhere else, but they need to be secure. Or you can use AWS Cloud HSM. Again, this is a Cloud HSM. I put AWS because AWS provides that functionality. So you can use a Cloud HSM, which is used to generate the keys. And then whenever you want to decrypt, you send it to them, and they will send you the clear text. So you are never storing those keys. And then there are access controls in place where if you want to access the HSM in the cloud, then they will make sure that it is just you who is accessing it. So they have some controls there. If it is a medium security use case, you can use some vaults to store the keys. Again, so like these are just like different methods you can do, but the bottom line is you should not store any system credentials or private keys in plain text. There are a lot of solutions available out there that you can use to store it securely. Now, another thing is whenever you are storing the data in the cloud, right? We are seeing now, just recently, we are hearing a lot about the Equifax hack. And like just yesterday, I was reading about it, and they were saying that like lot of this data was sitting in plain text. So when all of this data was stored in the database, like again, this story is evolving, so don't quote me on this, but what we need to do is whenever we are storing the data, right, we have to store it securely. So if we are storing any personal information, personally identifiable information, we need to encrypt and store it. Now, you can store it in the database, but either you can encrypt it at the field level, or you can encrypt it, you can encrypt the whole database, and you can store it, right? User passwords or pins. Again, if you are even if you have a database that you are encrypting the whole database, the user passwords or pins should never be encrypted. They should always be hashed. I provided some algorithms here that are recommended for this. So if you are using user passwords or pin, you can use the password key-based derivative function 2, or you can use the HMake SHA-256 or bcrypt or scrypt algorithms. Again, the user passwords or pins, you should never be able to recover them. It's like hashing is like breaking a glass, right? So if somebody, you should always generate a hash for the user passwords and pins. Never, ever encrypt them. Always hash them. Credit card numbers. If you are storing credit card numbers, you have to tokenize them. Tokenization is different than encryption because when you encrypt, it creates a big blob. Like if you look at, it's a big alphanumeric blob that it creates. Tokenization is a format preserving. So a 16-digit card number will give you a 16-digit token. But that token is such, so there can be two types of tokens. There can be a reversible token and an irreversible token. So in reversible token, what you're doing is you are using format preserving encryption like FF1 and FF3. So again, there is a NIST paper on it. So if you guys are interested, you should go check it out. So what that does is it uses some kind of an encryption, and it gives you the token which is mapped to that credit card number. And then if you give it that token back and it uses the same key, it will give you the credit card number back, right? So that is reversible token, where you are able to now decrypt that token based on this algorithm. Irreversible token is where you have created a pre-generated list of lot of numbers, right? And then when a new card comes in that you want to tokenize, you are just picking up one number from it and then associating with it and storing it internally. So that is like that has no association with that particular credit card number. The only association is that you just happen to pick that number from your random list of tokens, and you are just assigning that to it. So it's an irreversible token, right? You can reverse it, but you need access to that mapping database to get it. So for credit card numbers, do tokenization. For SSN or tax IDs or financial account numbers, you can either do tokenization or semantic encryption, again, based on your use case, what you want to do. Because if you have a use case where somebody is saying that, oh, we are using this SSN and we want a 9-digit number only, we cannot have this big alphanumeric like encrypted blob, then you can use tokenization. Otherwise, you can use semantic encryption. System passwords. Again, system password is something that you have to, it cannot be irreversible because you need the system passwords to access the downstream system. So it has to, you need to get it back in the clear text. So you have to use, you can either use AES 256. And then like if you have session tokens, access token, refresh token, right? So if you are using OAuth and you are getting a refresh token back from the provider, you are storing it, then don't store it in plain text. You have to store it, you have to encrypt it and store it. So if you have to store any of this, either in your cache, so sometimes what will happen is you will like session tokens, access tokens, they are short-lived, and you have to store them just for like 30 minutes. Refresh tokens are long-lived, so you have to store it in the persistent storage. But even the session tokens and access tokens, you need to make sure that even if you're storing in something like Redis cache or memcached or something like that, you always encrypt it and store it. So this data encryption is very important, right? So field level encryption for highly sensitive fields, such as passwords, credit card numbers, these are all field level because you are encrypting them on a field level. And then like if it is a big database that you want to encrypt, then personally, the PII data you can encrypt at rest. Okay, this is the 10th important thing that we need to do. Don't forget about, like, we did all of that, but still input validation is very important. Whenever we get an input on our microservices, we need to not assume that the clients would have done it. When we get it, we have to do it also. We have to have the CSRF tokens in there, in the state parameter. If you are using OAuth or something, you have to make sure that you have that. Again, it depends on your use case. You don't have to have it for everything, but you have to just figure out what your use case is, and then like provide CSRF tokens for that. You still have to do output encoding, so that if your microservice is giving the output to the web browser, then the web browser is not interpreting that as a code, and it is interpreting as data. So that output encoding helps in that regard. If you are doing the DevOps, then you need to make sure that you are incorporating the best of security in all the DevOps processes. So like in DevOps, if you are setting up some stacks, you write a chef script so you need to make sure like you have security in mind whenever you are writing all those scripts. So you have the correct like security groups, roles, you are opening the right ports. So you need to make sure that you have security in mind when you are creating those DevOps processes. Secure configuration, again, like even if you are using cloud, but if you are configuring your software, you may leave big holes in the configuration of your software. So it's very important to configure your software securely. And you need to be current on all the patches. Like again and again, this is one thing that we have seen so many times, where we continue to see security events happening because one of the servers was not patched. Like this is the story that is getting repeated so many times, over and over again. So you need to make sure, like even if you're using cloud environments, anything that you're doing, you need to be current on all the patches. Pen testing, importance of pen testing does not go away, because if you miss something, then pen testers are going to find them. And then when you are developing, you need to also do white box and black box testing. So those are all the things that, again, this is like a catch-all for all the things. But again, it's very important to do all of those.